Ja, då. Kommer inte mer. Okay. Well, good afternoon and welcome. My name is Gunnar Benselfelt. I'm working with Atlas Copco. I'm the product specialist for pumps. And the pumps has been my area for 20-some years. And I have got the task to talk a little bit about draining mines. Atlas Copco, as you know, are committed to sustainable productivity. And that's for you. In a short time, I will try to cover the essentials of pumping in mines. And there are different kind of pumping, if it's talking about underground mines or open pit mines, and also about maintenance, because I know that the main issue about pumps is that the cost for maintenance are quite high. It's actually much more than investing in the pumps. If you look at the pumps that can be used for dewatering, we have these type of pumps. We have electrical submersibles, engine-driven, either with diesels or with electric motors. We have positive displacement pumps, hydraulic submersibles, and pneumatic submersibles or pneumatic centrifugal pumps. If we look at an underground mine, the pumps that are used mainly are electric submersible pumps. Engine-driven pumps, you can see some areas you don't see any diesel-driven for natural reasons. And you have some electrical-driven to push out the water, we'll come to a little bit later on. There are some few mines that are using pneumatic submersible pumps. A pneumatic diaphragm pump like this is very limited in flow, but it gives a very, very high pressure. I've only seen it in one mine, and that is in Elk Grove, Nevada, where they had not very much water, but they had very high heads. So there they use that pump. If we look at open pit, there we find mainly electric submersible and engine-driven pumps, which we call end suction pumps, where you have a suction hose and you have a delivery hose. What we typically do with the submersible pumps in the underground mine is that we are transporting the water in the tunnels and in the pits to some kind of water collection area, sedimentation tank, where we try to sediment the tank or the water. And here you very often have an electric dry installed pumps, what I call engine-driven pumps with a suction hose to just push out the water, while the electrical submersible pumps move the dirty water, which is full of solids, full of sedimentation. This is normally how it looks like, and this is one way they're using the submersible pumps. This is the most wearing pumping you can do, because this is in front of the drill rig. You drill in the mountain, there's water coming from the mountain, and there's water coming from the drill rig, and you have all these drill scales, and it could be hard granite, and that is very wearing pump. People used to ask me how long lasts a pump, and a pump here usually lasts maybe 2, maybe 3 months, because such a tough pumping. I have had an issue today about this, because very often they hand carry this pump. This is not a very good way of carrying the pump, as these boomers, these drill rigs, they are very, very well tuned for aiming and drilling correct. And then when you put a pump there, there's a lot of kilos on that could sort of change all the aimings and things like that. So, and LKAB, they were very worried about the weight, how much you carry, so they were looking for very lightweight pumps so they could move around by hand. And in order to move the water in the mine, it usually looks like this. Here they have tried to make a sedimentation tank and to pump fairly clean water. They have not been very successful because they haven't emptied these tanks. And the reason for doing this are several. First of all, you try to pump as clean water as possible. The longer the pump lasts, much longer the cleaner water you can pump. And also the sedimentation, which is actually ore, is if you can keep it here, gather it here, you can process it later on. And also for environmental reason, because if you pump these solids out, they are very often, depending on what kind of mine you have, is environmental issues. You would like to pump out as clean water as possible because it is actually cheaper to treat the water, the less solids you have in it. If we look at an open pit mine, it could look like this, not a very beautiful installation. In an open pit mine, you normally make the bottom a little bit slope, and the water goes by gravity to a corner where you have some kind of sedimentation tank. Or it can look like this. This is a quarry in Peru doing the same thing. You can see the big difference between the two. Here they have a float switches device, which is level control. The pumps are only running when there's water, and they are not pumping on snore. They are hanging there. They are not sinking, not pumping the mud. They have even a strainer around it, and you can imagine how much longer this pump will keep up compared to this, where they just throw them down and they pump all kinds of solids. Big open pit, you can have these end suction pumps, put on barges, suction hose that push or move the water around. Oops. This is, I talked about maintenance costs, which is a big issue. And what we're trying to do is to keep the pump alive as long as possible. And as I mentioned, sedimentation tanks is one good way of extending the lifetime of a pump. And here, as I said, they tried very well, but they were not very successful because they didn't empty this area here. And you can imagine how much cleaner water the pump will be dealing with here. And sedimentation tank doesn't need to be very complicated. You can have just a container and put a baffle in there, and it will work greatly. As I mentioned, you can see one pump that was hang, which also pumps cleaner water. It doesn't dig itself down. Said it didn't look very nice, more like this. And this is what I said earlier. Here they hang the pump. The pump is pumping more clean water. Some kind of level control for this. And when we are talking about repairing and service, I mean, that's what we are discussing a lot. And why is that such a hot issue? Well, pumps are vital. In a mine, you have to have the pumps, because if it is flooded, the machine will be flooded, you cannot work. You can spend a lot of money trying to keep the machines, move them around, but it doesn't work if there is water. So fast repair is required, or you have to have spare pumps to put into the mine. Preventive care is rarely seen in a mine. If you look at the submersible pumps, they run till they die. There are programs that can be used. I mean, the pumps are designed, so there are preventive care that can be done. I used to say in a car, it is natural to change oil, which it is. Everybody does that. In a pump, well, not in a mine. It never or rarely happens. So the result is pump runs till it stops. And when they stop, they are broken. I mean, they are beyond maintenance. Now we're talking about repair. Repair costs are normally higher than investment costs for new pumps. Not each repair, but you invest in a pump once, and then you probably repair it 10, 15, maybe 20 times before it dies. So some kind of rational service program and easiness to repair pumps are needed. So what can we do? Well, if we try to observe the first malfunction of the pump, take it out of business, as soon as it shows any signs of failure, don't keep on pumping, because that will cost a lot of money, probably burn motor. As I said, try to have the pump installed so as clean water as possible pumped. Try to find installation where regular service intervals can be applied. I mean, there are a lot of small areas where the pumps are more or less fixed installed. You don't move them around. If you can have it every 3 months or whatever, pick them up, check the oil, put another pump in there, and service, maintenance, maintain the pump. And of course, try to find a high quality pump that is made for this kind of tough pumping. And of course, we as a supplier of pumps, we are trying as hard as we can to make the pumps run as long as possible. So we have two important areas, and that is of course the wear parts. That is the impeller and the diffuser that's actually doing the pumping, that is pushing all the water and pushing all the sediments, all these hard degrees of whatever it is you mine, if it is granite or slurry or whatever it is. And also the motor unit has to have a high degree and protection of the motor. I mean, it has to have a high degree. I mean, there's classifications of the motor, and the higher the classification is, the more heat the motor can take, the more heat, the more punishment, so to say, it can take. And also protection of the motor. There is a lot of sophisticated ways to protect the motor from simple ways by heat and by overload, and also there's a lot of electronic ways also. Electronic devices in mine pumps are rarely used because of the fluctuation in electricity. And the heart of the pump, which is the seal system. We have a rotating shaft, we have a drive motor, we have a wet end that is pushing water. And that part, which is the heart, we can easily replace the whole unit in one go, which means that we can speed up the service quite fast. And that is this part here. And we have several advantages. Pressure compensated seal system, which means that we are taking away the pressure of the power, so to say, from the impeller. Wear parts here, we are talking about high chrome steel, we are talking about natural rubber. So we are doing our best to keep the pumps running. So what we can say that our pumps, our electric submersible pumps, from 1 horsepower, from 1 kilowatt up to 54 kilowatt, or our diesel-driven pumps, which we will be introducing in September this year. They are all designed for doing what you need. Try to keep the mines dry. And my time is out. If you have any questions, technical questions about pumping or pumps, I am available at the Atlas Copco stand the whole day and tomorrow. So you are very welcome. I'm very happy to talk pumps with you guys. Thank you for listening.